Okay, effect of diluting acids on their pH. This is lesson C5.8a in the booklet. We need to refer back to C4 work here on concentrations. Concentrations are always measured in moles per decimetre cubed, and a decimetre cubed is the same as 1,000 centimetres cubed or a litre, and you'll need that when you come to convert centimetres to decimetres cubed for exam questions. If we take various concentrations here, so I've diluted these by a factor of 10 each time, the concentration can be written in standard form. If you're unfamiliar with this, refer back to your maths texts. So a concentration of 1.0 can be written in standard form as 1 times 10 to the power of 0. 0.1 is written as 1 times 10 to the power of minus 1, and so on. The power of the expression relates directly to the pH. So minus 1 becomes pH 1, minus 2 becomes a pH 2, and so on. Okay? Looks complicated, but actually it's fairly straightforward. So what does this mean in terms of diluting acids? The dots here represent H+ ions. Obviously in a 1 mole per litre solution there'll be billions of these in the solution, but we're using 10 dots here just to illustrate. If we take 1 centimetre cubed of that acid and we add 9 centimetres cubed of water to it to take it to a total volume of 10 centimetres cubed, we end up with a solution that is 10 times weaker, 10 times more dilute. So therefore its concentration is going to be 0.1 moles per litre. And you can see here the concentration of your H+ ions is 10 times less. So it's a weaker acid, so expect its pH to go up. Okay? An example of the sort of exam questions you're going to get: 0.005 moles of HCl in 500 centimetres cubed of water. First thing we need to do is calculate the concentration. Referring back to C4, that is moles divided by the volume, which is 0.005 moles divided by 500 centimetres cubed. However, concentration is always in moles per decimetre cubed, so we have to convert that into decimetres cubed. So we divide it by 1,000. That gives us a final concentration of 0.01 moles per decimetre cubed. So the pH, if we refer back to our table over here, is going to be 1 times 10 to the minus 2, which is a pH of 2. Okay? You might also need to read the notes in the booklet. They're very useful. Some acids, and in particular sulfuric acid, produces twice as many H+ ions as HCl and nitric acid. Okay, so sulfuric acid you'll have to double your figures when it comes to the concentration of H+ ions. Okay, I'm hoping that will be enough information for you to have a go at those questions in the booklet. Okay, see you later.